Hello everyone, this is Pre-Calc Lesson 62, Abstract Coefficients and Linear Variation. So abstract coefficients are exactly as they sound. They are coefficients that are not numbers, they are letters. So we will start having equations like this. It says solve for y. You'll have ax plus by equals c, and dx plus ey equals f. It's a system of two equations, two unknowns, like we had before. The difference now that you can obviously see is we don't have any numbers to work with, we just have letters. So we're still going to use elimination to solve, and I'll show you what that looks like. I'm going to multiply this top equation by negative e and this bottom equation by b. So on top, I'll have negative aex minus bey equals negative ce. And on bottom, I'll have dbx plus bey equals fb. You see, if I add these together, my y term cancels, okay? Leaving me with, here, I'll have db minus aex equals fb minus ce. And I solve for x by doing fb minus ce over db minus ae. Now I know it says solve for y. I wanted to show you this, okay, to show you what it looks like. Let's do the same thing to solve for y. Now at this point you could plug in this value for x and solve for y, or you could use elimination again. I think elimination is easier. So I'll write down my original equations again. ax plus by equals c, and dx plus ey equals f. Okay, I'm going to multiply this top equation by minus d and this equation by a, giving me minus dax minus bdy equals minus cd, and I will have dax plus aey equals fa. I add them together, my x's eliminate, and I get ae minus bdy equals fa minus cd. So y equals fa minus cd over ae minus bd. There you have it. Okay, let's do another example. We're going to solve this one for x. We have a1x plus b1y equals c1, and a2x plus b2y equals c2. I'm solving for x, so I'm not going to do what I did up here. I'm just going to jump right into it. I'm going to eliminate y. So I'm going to multiply this top equation by minus b2 and this bottom equation by b1. So I'll have a1 b2x minus a1 b2x minus b1 b2y equals minus c1 b2. And I will have a2 b1x minus b1 b2y equals c2 b1. Okay, I'm going to add these together. My y's are eliminated. I get a2 b1 minus a1 b2x equals c2 b1 minus c1 b2. Okay, and I solve for x by dividing both sides by a2 b1 minus a1 b2. So I get x is c2 b1 minus c1 b2 all over a2 b1 minus a1 b2. Okay, that one's a little bit harder because you have to keep all of your a1s, a2s, b1s, b2s, c1s, c2s in order, your 1s and your 2s basically in order. All right, now let's talk about linear variation. Okay, we've had before direct variation and inverse variation. Now we're going to have linear variation. And I'm going to show you what it looks like with an example. The total cost varied linearly with the number produced. Okay, I first need to create 2 points. So when 100 were produced, the cost was 700. Now we know that the items produced is the independent variable because cost is dependent. Cost depends on how much are produced. Okay, so that's why 100 produced was the x and $700 is the y. And then it tells us when 400 were produced, the cost was 2,200. Now I have 2 points. Okay, it says write an equation that gives cost as a function of the number produced. So I use these 2 points and I find the slope between these 2 points, which is the change in y over the change in x, right? I'm finding the slope the exact same way as I would if I was doing this a regular equation with 2 points. So I get 1,500 over 300, which gives me 500. Okay, sorry, 5. Silly. So now I will have y equals 5x plus b. Okay, and then I need to solve for b by plugging in one of my points. So I'm going to say 700 equals 5 times 100 plus b. So 500, 700 minus 500 gives me b is 200. So my equation is y equals 5x plus 200. Now your book will write it as c equals 5n plus 200. C is the cost, n is the number produced. I don't care if you do that. You can use y's and x's, but just so you can recognize it, these are the same thing, just different variables. Okay, that's linear variation. This shows us that it's varying linearly because it's the equation of a line. Okay, let's look at this example. The total cost varied linearly with the number of items produced. So again, we create our 2 points. 25 items produced, the cost was 1,300. And 23 items produced, the cost was 1,220. So I find my slope. I'm going to do 1,220 minus 1,300 over 23 minus 25. Okay, just the same as we would normally do. We get negative 80 over negative 2, which gives me 40. Okay, so I have y equals 40x plus b. Then I plug in one of my points. 1,300 equals 40 times 25 plus b. And that gives me b is 300. So the equation of my line is y equals 40x plus 300. Okay? Now it says, find out what it would cost if 100 were produced. I know that y is my cost and x is the number that is produced. So I plug in 100 for x. So I will have 40 times 100 plus 300, and the cost would be 4,300. Don't forget to put your dollar sign. Okay? That is linear variation. So now you can get problems that have linear variation along with direct and inverse variation. Okay? So that's all for today. I hope it goes well for you.